Okay, so the second type of example we'll see in section 5.1, I like to call the show that example. And here's what I mean. So to start off with, we're going to say that, there we go. We're going to say show that cosine of x plus sine of x times tangent of x simplifies to secant of x. So in this problem, you're sort of given the answer, right? You're given that this should look like secant of x. So I've essentially told you as the teacher what I want you to do. What I'm sort of interested in is seeing what your process is, seeing what your steps are. The reason we do this is because it doesn't always simplify to a single trig function. In this example, it does. It doesn't always simplify to a single trig function. So we sometimes want to simplify to other functions. Okay, so let's go ahead and start this off. Now I don't see any squares. Nothing is being squared. So I think what I'll start off by doing is changing this to using the quotient identity to sine over cosine. Now hopefully you're going to start getting pretty good at multiplying fractions, but I will take this an extra step first. Just to remind you that when you multiply a fraction, it looks like this. So this gives me cosine of x plus sine squared of x over cosine of x. Now I do see a squared popping up here, so my guess is that we're going to have to use the Pythagorean identity in a moment. But I don't really see a +1 or -1 or anything anywhere, so I think what I'll do to start off with is add these together. Now I'm going to write down adding fractions because technically this is cosine of x over 1. So in order to get a common denominator, I just need to multiply cosine of x over 1. I need to multiply this by cosine of x over cosine of x. All right. Now I've gone through this in quite a bit of detail at this point. If you want to skip some of these steps, you can. You might just recognize immediately that you'll have cosine squared of x plus sine squared of x over the common denominator, which is cosine. So you might be able to skip some of these steps in here. Some of the multiplying and adding fractions might be a bit more straightforward. Please just make sure you don't make mistakes. Okay, so now let's take a look. We have cosine squared plus sine squared. Well, that is my favorite identity. So that just equals 1. 1 over cosine of x. So at this point, we've just kind of been doing stuff. We've been working through, trying to make this look a bit simpler. Let's go back and see what the answer should be. I need the answer to be secant of x. So at this point, I'm pretty much there because the reciprocal identity tells me that this just equals secant of x. So I'm done. I got to the point where this is actually the answer. Again, I don't really care about the answer because I'm giving it to you. I'm more interested in seeing your work. So just as a note here to annotate this, I use the reciprocal identity for this one. So this problem could have been given either way. I might have said, I might have done it one of the first examples. I could have said just rewrite this as one trig function with no denominator, but I decided to do this as a show that example. Okay, let's try another one. So in this one, we're going to show that 1 over secant of theta minus 1 plus 1 over secant of theta plus 1 equals 2 times cotangent of theta times cosecant of theta. Okay, so notice in this one, I've just given you an equation, or it looks like an equation, but really we don't actually know that this is true yet. So we don't, because I'm telling you to show it's true, you don't actually know that this equation is true, or I should really say identity is true, but I'll leave it at equation. Now, usually what happens with these problems, it's kind of like what I did above, where I said show that this simplifies. I don't know why there's a T there. Okay. That simplifies. So really, you can think of this new problem as show that the left side simplifies to the right side. So this is kind of the, whoops. This is kind of the answer in this case. I think I might have, yep, okay. Okay. Sorry for the issues there. We should be good now. All right. So let's start off with the left side. Let's say 1 over secant of theta minus 1 plus 1 over secant of theta plus 1. Now I want you to get to the point where you immediately think I'm adding fractions. Let's do a common denominator. I'm going to get secant of theta plus 1 plus secant of theta minus 1 all over those two denominators being multiplied together. So you'll notice what I did is I did a common denominator, so I multiplied this top and bottom by that, and then this one by the other denominator. Right? And so that gives me this new expression. This can be reworked a little bit. 1 minus 1 is 0. Secant plus secant just gives me 2 secant. Now in the denominator, I'm going to do what I did before, which is distribute. So we're going to distribute everything out. And I'm going to end up with secant squared of theta minus 1. Hopefully, you're starting to recognize when there's a squared and there's a 1, most likely we're going to end up using the Pythagorean identity. So let's take a look here. There's a Pythagorean identity that says 1 plus tangent squared of theta equals secant squared of theta, which is exactly what I have here if I subtract the 1. So that tells me that all of this just equals tangent squared of theta. So I'm going to end up with 2 secant theta over tangent squared of theta. Now I've kind of forgotten what my original goal was. So let's go ahead and take a look up here. Excuse me, I need to get to this point. This is my answer, cotangent and cosecant. So I think what a good thing to do at this point might be to get everything in the numerator. So I'm going to bring this tangent squared, since that's all that's in the denominator, up using the reciprocal. It still doesn't quite look right. I do see a cotangent. So at this point, it might be good, when you get stuck like this, it's good to convert everything back into sines and cosines. So let's try that out. Let's do 2. It's going to be 1 over cosine of theta. And then this is going to be cosine squared of theta using both. This was a reciprocal identity to start with, and then a quotient identity. A good thing to do maybe in these videos is to pause and make sure you know what I'm talking about. And so now I get 2, I have a cosine squared theta over cosine of theta. So that's going to cancel a little bit, divide out to 1. And then I end up with 2 cosine of theta over sine squared of theta. Okay. It still doesn't quite look right. So let's take a look back up here at my answer. I need cotangent and I need cosecant. Now I know cosecant is 1 over sine. And I know cotangent is cosine over sine. So let's try to make this look like that. I could rewrite this as cosine of theta over sine of theta times 1 over sine of theta. And now we pretty much have it. So if we take a look at this and this that I have in parentheses, using our identities, we end up with what we wanted. So let's just double check 2 cotangent and cosecant, 2 cotangent and cosecant. And so we are done. All right. So that definitely took a bit of work to get to that point. We used a couple different identities, reciprocal and quotient, kind of going back and forth. It's good to familiarize yourself with these as much as you can, especially the quotient and reciprocal, because you'll be using those in pretty much every problem. So it's a good idea to start getting really good with those. This type of example is a little bit different because I essentially give you the answer. So with the show that examples, you're given the answer, and I'm more interested in your work. So really the goal is to show me the work in order to get to that final answer. And those are the only 2 types of examples we're going to do because those are pretty involved examples. So we won't do anything more than that. You'll just have to practice these types of problems.